Next, we'll work a problem with Henry's law. We'll look over the example problem and then we'll work the for practice problem together. What pressure of carbon dioxide is required to keep the carbon dioxide concentration in a bottle of club soda at 0.12 molar at 25 degrees C? We know that Henry's law states that the solubility of a gas, in this case CO2, is equal to the Henry's law constant for the gas times the partial pressure of the gas. In this case, we're asked to find the partial pressure, knowing the solubility that we want, and we can look up the Henry's law constant from a table. So we look at table 14.4 in the Tro book and we find the Henry's law constant for CO2 to be 3.4 times 10 to minus 2 molar per atmosphere. We were given the solubility of the gas at 0.12 molar. So next we just solve for the partial pressure of CO2. We see here that the partial pressure of CO2 is equal to the solubility divided by the Henry's law constant. The solubility is 0.12 molar and the Henry's law constant from the table is 3.4 times 10 to the minus 2 molar per atmosphere. So molarity cancels, atmosphere comes back to the top, and we're left with the pressure of 3.5 atmospheres. Now we'll work the for practice problem. Determine the solubility of oxygen in water at 25 degrees C, exposed to air at 1 atmosphere. Assume a partial pressure for oxygen of 0.21 atmospheres. We know the solubility of a gas is equal to the Henry's law constant for the gas times the partial pressure of the gas. In this case, we're considering the solubility of O2 equal to the Henry's law constant for O2 times the partial pressure for O2. We can look up the Henry's law constant in the table at 25 degrees C. So we see that the solubility of O2 is equal to 1.3 times 10 to the minus 3 molar per atmosphere. We get that from the table, times 0.21 atmospheres, which is the partial pressure for oxygen. Atmospheres cancels, and we get 2.7 times 10 to the minus 4 molar.